This video is on multiplying and dividing rational expressions. So as a warm-up, we're going to simplify a rational expression, which is something that we did in 2.1, and then state the restrictions on this. So in order to simplify this expression, we have to factor the bottom. So we're going to have to factor lots in this unit in order to multiply, divide, and later on when we add and subtract as well. So we need to factor the denominator in this case, because the top of the numerator, it's already, can't do much with it, so it's going to be x plus 5. And then to factor the denominator is do product sum integer. So the product is going to be minus 15. The sum is going to be positive 2. And so the two numbers are going to be a positive 5 and a minus 3. Because in this unit we're going to do lots of factoring, we want to do this as efficiently as we can. So one of the things that we're going to see is that if our a value is 1, or is just x squared, then this is just going to be factored to our integers. In this case, x plus 5, and then x minus 3. Okay, so you don't have to go through the actual steps of decomposing if the a value here is 1. So it just factors to this, and what happens now, we could reduce. So really, we could think of x plus 5 as a factor, as a group itself. And when we reduce that, remember we're left with a 1 in the numerator, and now we're left with x minus 3 in the denominator. So that's that expression simplified. And the restrictions are, in this case, x is not equal to. Well, this is really important. Now we go back and look at the original expression and what are the factors there. In other words, what's going to make the denominator 0 in my original expression once we have it factored. So in this case, because we reduced the x plus 5, we might forget that in terms of restrictions, but in this case, the restriction also includes negative 5, in this case also a positive 3. So here I made it as a separate note that the restrictions of the domain can be determined from the zeros, so we need to look at the zeros of the denominator, but of the original denominator specified in factored form. So in the success criteria for this section, we're about to multiply and divide two rational expressions with a simplified result. So we always want our answers in most simplified format, and then stating restrictions on the variable if it exists. And here's a hint: if we have a variable in the denominator, restrictions will always exist. And again, the idea of restriction is that we do not want the denominator to equal 0 if we substitute in a value for the variable, because we cannot divide by 0. So let's start off with a simple question. Not the best phrasing here. Maybe it shouldn't be solved, but it should be maybe evaluate. So we'll evaluate 6 times 5, so 6 over 15 times 55 over 14. So we go off and plug that in the calculators if we want. We know that when we multiply fractions, we do numerator times numerator, denominator times denominator. So in this case, we could go 6 times 55 over 15 times 14. And from that, we're going to have to sort of reduce that fraction to its lowest terms. One step that we could do instead of doing that right away is sort of factor our numbers. So 6 is going to factor to 2 times 3. And then 15 is going to have to factor to 3 times 5 as well. So we're going to multiply that to 55. 55 factors to 5 times 11. And then 14 factors to 2 times 7. Okay? So one thing that we could do right away is just even reduce within our fraction. So here we see that the 3's cancel out. So again, now we could just rewrite our expression all multiplied together now, because like I said, we multiply fractions, multiply numerator times numerator. So in this case, we get 2 times 5 times 11 over 5 times 2 times 7. And then here we could reduce, now we can see that, oh, there's lots of opportunity to reduce. We can reduce the 2's here, and the 5 and the 5, and finally we're left with 11 over 7. Okay? Because really when we multiply fractions is numerator times numerator, denominator times denominator, we could save ourselves one step in terms of when we have this part over here, is that instead of rewriting that, we could just sort of extend the fraction line and it says, well, really everything is multiplied together as the numerator and everything's multiplied together as the denominator, and then we could sort of simplify in that way, and we could save ourselves some from writing and therefore some copying mistakes. And in this case, we also would get 11 over 7 because we reduce everything. Okay, so here's another example. We go off and simplify this, so I might want to do the same things with the coefficients in terms of breaking down to its prime factors. So here it is going to be 2 times 3, and here we're going to get left with x squared all over 5 can't be factored anymore, so it's be 5xy times 15 is going to factor 3 times 5, and then we have x and y cubed all over 8 is going to factor. So here I'm going to break down to prime factors. This is going to be 2 times 2 times 2, y to the 4th. Okay. So this, if we do it this way, break it out to their prime factors and reduce, we know that our fraction isn't going to be able to reduce any further. So I'm just going to do that trick that I just kind of said above, and it's really I'm going to extend this fraction, and really everything on top is multiplied together, and everything in the bottom or denominator is multiplied together. And I go off and sort of start doing my reducing. So here 2 reduces 1 and 2 on the bottom. Can't reduce the 3's because they're on top, but I can reduce the 5 over there. I could do likewise with my variables. So here I have y cubed and y to the 4th. So that's going to cancel out with this, and I'm left with 1y on the bottom. And then likewise with the x cancels out over here. So we just got to be really careful and not be too messy with our canceling, because if you do too much or it's kind of scrambled, then it's hard to read what's left afterwards. So here I'm going to get 3 times 3, which is 9 in the numerator, and the x squared is all by itself now. And finally in the denominator, I get 2 times 2, which is 4, and I have a y times y, so I'm left with the y squared on the bottom in the denominator. So that's how we answer that question in terms of simplifying. And really, this is what we're doing is multiplying. We have multiplied rational expressions because here's one rational expression, just happens to be a monomial, and here's another rational expression has to be a monomial as well. Monomial divided by a monomial. So let's go into some more trickier questions. Although I would argue it's not really that much tricky as long as we sort of understand the concepts of what's going through. So here we're going to simplify and state the restrictions. So because my question is already in factored form, so being very generous here, I don't have to factor this, and maybe the very first thing it's just going to do is right off to the side, because most likely if I start canceling right away, I might forget the restrictions from the original question. So in this case, my restrictions here are x plus 4, that means x can't be a negative 4, and then x minus 5, that means x can't be a 5 because it would make either of those factors 0. So in this case, just reduce. I've reduced x minus 5, x minus 5. Really, this x plus 4 is a separate factor itself, and that reduces. And finally, the final expression we get is going to be x plus 1 over 2. And that's it. So this is really a unit I really like to do. I remember doing it as a student. It was fantastic because now this is a real purpose to factoring. And then once I factored, and then I could see all these things reducing and canceling out, and I get this small, simple expression at the very end. Somehow it's just very satisfying to me. Another nice thing I kind of liked about this unit is because it's almost a hint that I factored correctly when things are crossing out or things are being reduced. Now, I don't want to say that this happens all the time, but if I get a factor that's x plus 5 on the numerator, and again, a factor that got to be x minus 5 in the denominator, kind of sets off some red flags a little bit, saying, maybe did I factor that correctly enough? Because that's the whole kind of thing that we're looking at this unit is even a factor properly, and then the factors, the terms, canceling or reducing out. So here's a larger example. Here we're gonna, it's not factored for us, so we have to do a little bit of factoring, or more particularly, this side is not factored for us. So instead of doing the factoring within the question and doing lots of copying for the rest, we're just gonna factor things off to the side. So I'm gonna get x squared plus x minus 6. Well, if I'm gonna factor that, psi, We almost do this in our head almost. The product is -6, the product is 1, and in this case, the two integers are going to be 3 and -2. So like I said, if our coefficient to the x squared is just 1, in other words, it's just x squared, we could just use the integers as is. So it's going to be x plus 3, x minus 2. That's going to factor to that. The next one we're going to do, we just did above, I think, x squared plus 2x minus 15. This is going to factor to x plus 5, x minus 3. So this expression is equal to x plus 3 times x minus 2. And again, I'm going to sort of extend the multiply sign, save myself some copying. I know this is going to multiply the numerator of the other fraction, which is going to be x minus 3. This is going to be all over x plus 5, x minus 3, and x minus 2. So this is why I look at this question, and then I go, oop, there's an x minus 3. So that's going to reduce, and then x minus 2, this is where I'm really happy, because yes, it's so satisfying. I can reduce those, and now this expression looks really simple. It's just going to be x plus 3 over x plus 5, and again, I'm going to restate my restrictions. I wrote them up here on top when I was looking at my original expression, so I don't forget anything. So in this case, x cannot be -4 and cannot be 5. So in general, when we have rational expressions, we'll multiply together. So in this case, p over q times r over s, which is really multiply numerators together, p times r, and multiply denominators together, q times s. And where restrictions come from is that q cannot be 0 and s cannot be 0. In other words, we're looking at our denominators, and the denominators cannot equal 0 because we cannot divide by 0. So when stating restrictions, we examine the denominator of the unsimplified expressions. When I say unsimplified, doesn't mean that's unfactored. That means we haven't reduced anything. Okay, so even when it's factored, it's still unsimplified, but we haven't reduced anything because we need to worry about the original expression. So let's look at dividing, and we kind of look at the same way. Let's start with some numbers a little bit. So I can take the same strategy. I'm going to break this down to the prime factors. So it's going to be 2 times 3 over 3 times 5. So that's what 15 breaks down to. Divided by, well, 9 is just 3 times 3. And then 12 factors to 2 times 2 times 3, because the factor is 4 times 3, and break it down further. And again, when we divide fractions, we really multiply. So instead of divide by 9 by 12, we multiply by the reciprocal. In other words, we flip our fraction, so we're going to be able to multiply by 12 over 9. So I'll rewrite this. So that's what we don't want to reduce yet. Maybe the one thing we could do is still reduce within our fraction. So here the 3's reduce, and the 3's reduce over here. So we reduce within our fraction. So now that we have that reduced, we're going to have 2 over 5 times, well, we're going to reciprocate our the fraction that we're dividing by. So that's going to be 2 times 2 over 3. So in this case, can I reduce any further? Nope. So it's going to be 2 times 2 times 3, which is 8 over 50. Okay, so we take those same strategies that we did before, except now that before we go off and multiply, sorry, instead of dividing, we're going to multiply by the reciprocal. So likewise, when we have a big rational expression, okay, so here we're going to start with something big right away, and it looks messy because I have 1, 2, 3, 4 expressions, polynomials that I have to go off and factor. So that's why I said factoring is going to be doing a lot. Favorite F word in math now for this unit. Usurps our other previous favorite F word, which I can't say. Just as a reminder that we have to do every single time on almost all the questions that we have in this unit. So let's quickly factor x squared plus x minus 20. So there I can see my two integers are -20. So the sum product is -20. The sum is 1. So my integers are going to be 5 and a -4. So this is going to factor x plus 5, x minus 4. I'm going to do the other ones a little bit more quickly. X squared minus 6x. Well, this is going to common factor out just an x, so I get x minus 6. Maybe the other one I'll do over here off to the side is x squared minus 12x plus 36. And I recognize that this is going to be a perfect square trinomial, so this is going to be x minus 6 quantity squared. And the last one is going to do a little bit more because I actually have to decompose this one because the coefficient to the a is 2. So the coefficient of a is 2. So I cannot just use the integers, but I have to go off and decompose. So here was my product is going to be 20. Sorry, not plus 5. It's not plus 10. It's plus 5. I was writing the product already. Got a little ahead of myself. So the product is 10, and my integer, sorry, my sum is going to be 11. So the integers, two numbers that add to multiply to 10 and add to 11. It seems like, oh, there's 9. We go through it, but we forget the common factors of just 10 and 1. Gives us 11. So here I'm going to decompose 2x squared plus 10x plus x plus 5. And then I factor out a 2x here. I'm left with an x plus 5. And there I can't factor anything, just a 1. But that's okay because I'm left with an x plus 5. So this is going to factor to x plus 5 to 2x plus 1. Okay, so really that's the majority of this question. It's just factoring. That's what we're going to spend most of the time on. And then once we got everything factored properly, just go back and copy this out. So x squared plus x minus 20, we said that factors to x plus 5 times x minus 4. And then the denominator is going to be x times x minus 6. So we're going to divide by 2x squared plus 11x plus 5. So we set that factors to x plus 5 and 2x plus 1. And the denominator is x minus 6. And I'm going to write this out in full because I know that I'm probably going to hopefully reduce something like that out. So maybe I'm going to pause right here and think, well, what are my restrictions going to be? Because again, we want to look at my original expression before we reduce or before we simplify. So let's look at the denominators because we know that denominators cannot be 0. So in this case, quickly looking at this, you can kind of see, maybe I'll just write this over here for now. X cannot equal, you can see 0, 6. So 0 is from here, 6 is from that, and the other one is also x minus 6. So again, it's just a 6 there, and it almost hints to me that I probably could reduce some of this later on because instead of dividing by that fraction, I'm going to multiply by the reciprocal. So there's nothing I could reduce as in the original fractions themselves. So here we get x plus 5 times x minus 4 all over x times x minus 6 multiplied by x minus 6 times x minus 6 over x plus 5 to x plus 1. So now we go off and start reducing. So x minus 6 reduces there, x plus 5 reduces over there, and that's as far as we can go, but that's actually pretty good. Things are a lot more simplified. So here I'm going to write everything across. So I get x minus 4 times x minus 6 all over x over 2x plus 1. Okay, so is this simplified? Absolutely. Okay, don't think that you have to go off and expand that and rewrite that when it's expanded. Leaving in factor form is simplified, and you can absolutely leave your answer in that sense. In fact, I wouldn't do any more with that. So that is completely simplified. The last thing we do is you need to state our restrictions. So in this case, x equals 0 or not equals 0, and x can't be 6. But we have to take a second to look at this division because it's not as straightforward. So one thing that we do understand is that the denominator of our fractions cannot be 0 because we cannot divide by 0. That's what the fraction means. Well, because we're dividing now, it's a little bit more tricky. Because when we're dividing, that means this entire divisor cannot be 0. So how can that divisor could be 0? Well, that means we also have to look at the numerator of a divisor. Because if that is 0, that means this entire thing is also 0, which means that we're dividing by 0. So here, when we're dividing rational expressions, we also need to look at the numerator of a divisor for the zeros as well. So we weren't quite complete. We have to go over here as well, as that x cannot be -5 as well for this term. And then in this case, let's make sure we work this out. Take a second to work this out. Make sure you're not messing things up with their signs. 2x plus 1, and what makes x equal 0 in that case? Well, it's going to be 2x equal to -1. So x, in this case, is a half, or really x cannot be a -1/2. So really, the complete answer to restrictions is that x can also not equal -5 and also cannot equal to -1/2. So there's a final answer right there. Okay, so once we get a division, things are a little bit more tricky. Okay, so this is one thing that we need to remember. So here's a note. It's almost the same as multiplying. We have P over Q divided by R over S. Well, really going to take P over Q and multiply the reciprocal, in this case S over R, and now it's just a straight multiplication question. But here we need to not only look at Q and S for our denominators, for our zeros, and for our restrictions, we also have to look at R. In other words, we have to look at 3 or 4 places for our restrictions. Okay, so that's multiplying, dividing by rational expressions. It's actually kind of really straightforward. Hopefully it's not too difficult. It's really an extension to the previous section when we simplified, because when we multiply, it's really numerator times numerator, denominator times denominator. So it looks like a big simplification question. The really tricky part in this unit, as the one I just covered here, is going through the restrictions, especially restrictions when we divide rational expressions. So looking back at the video, I just realized I made a couple of mistakes. In the very first one here in the warm-up, when I simplified, I realized I forgot to copy the x over here. Like I said, 90% of our math mistakes are copy mistakes. So here we have x in the denominator, so therefore we have x squared divided by x, which just reduces to just 9 over x. The other mistake that I made when it's coming down to this question, I got confused with the restrictions in this question up here. And I copied down the restrictions down here, so the restrictions in this question is not correct. So the actual restrictions are x can't be, and I need to look at the denominator of my original expression before I reduce. So that should be x cannot be -5, 3, and 2. So that's the restrictions on that question.